Let us learn about skew-symmetric matrices. Okay, so a square matrix. Have a look over here. Have a look here. So a square matrix A equal to Aij is called skew-symmetric matrix. Okay, so a square matrix A equal to Aij is called as skew-symmetric matrix if and only if. Okay, IWF if means if and only if A transpose is equal to minus A, or that is Aij is equal to Aj for all I comma j. Okay, so let us suppose there is a matrix A like this. There is a matrix A which looks like this. Okay, so what does the definition say? It will be called as skew symmetric if and only if A transpose is equal to minus A. Okay, so let us take its transpose. Suppose there is a matrix like this and we are taking its transpose, so its transpose will look like this. Okay, so first row will become the first column, second row will become the second column, and third row will become the third column in transpose. That is how transpose is defined. Now you can clearly see this, that A transpose comes out to be equal to minus A. This is A transpose and this is A. If you multiply this A by minus sign, what will happen? 0 will remain unaffected. 0 will remain unaffected. 2 will become minus 2. Minus 3 will become plus 3. Minus 5 will become plus 5. Minus 2 will become plus 2. Plus 3 will become minus 3. Plus 5 will become minus 5. Okay, so clearly when matrix A is taken and its transpose is taken, the transpose is coming out to be equal to minus A. Transpose is coming out to be equal to minus A. So this is satisfying the skew symmetric matrix definition. This is satisfying the skew symmetric matrix definition. This particular definition it is satisfying. Now we want another definition also to be satisfied. That is Aij is equal to minus Aji. Aij is equal to minus Aji. This particular condition for all I comma j, this particular condition should also be satisfied for all I comma j. Aij is equal to minus Aji. Okay, so this particular condition should also be satisfied. Now how is it being satisfied? Let us have a look. Compare this matrix A with this. This is I am telling you through example. Okay, compare this matrix A with this. So A11 corresponds to 0, A12 corresponds to 2, A13 corresponds to minus 3, A21 corresponds to minus 2, A22 corresponds to 0, A23 corresponds to minus 5, A31 corresponds to 3, A32 corresponds to 5, A33 corresponds to 0. Okay, so this is the thing. Now have a look. A12 is 2, A21 is minus 2. Okay, so A12 is equal to minus A12. This condition is satisfied. This particular condition is satisfied, that A12 is equal to minus A21. Okay, because A12 is equal to 2 and A21 is equal to minus 2. So this condition is being satisfied. Okay, this condition is being satisfied. Now have a look at this. A31 and A13. Okay, so A31 is 3 and A13 is minus 3. Okay, so A31 is equal to minus A13. This condition is also being satisfied. Now have a look. A32 is equal to minus A23. Is it being satisfied? Let us have a look. A32 is equal to 5 and A23 is equal to minus 5. So A32 is equal to minus A23. Okay, this condition and this condition are also being satisfied. It implies that this condition is correct. This particular condition is correct. That is Aij is equal to minus Aji for all I comma j. For all I comma j, Aij is equal to minus Aji. Aij is equal to minus Aji for all I comma j. So this is the condition which this particular matrix satisfied. So such matrices are called as skew symmetric matrices. So a square matrix A equal to Aij is called a skew symmetric matrix. IWF if means if and only if, that is it is a necessary and sufficient condition that A transpose will be equal to minus A, that is Aij will be equal to minus Aji for all I comma j. Okay, so these conditions are being satisfied by this example matrix. By this example matrix, these two conditions are being satisfied, and hence it is a skew symmetric matrix. This matrix A is a skew symmetric matrix.